Welcome back to my channel. My name is Rakshit Subramanya and today I am going to be talking on the topic page replacement in operating systems. So let's move on. Let's have an introduction. Page replacement is a crucial concept in operating systems. It involves swapping out pages from memory to disk when required. The goal is to optimize memory usage and improve system performance. So for you to understand what actually page replacement is, here you can see the diagram. So consider this cylinder as your storage, and this cube here, which is named as physical memory, is where your data is processed. Is from here it is processed. So now if you see on the left, you have the page table which will be showing the direction to your memory, or where has the page should be brought and placed and taken back once again. So sometimes what happens, as you can see in the middle physical memory here, there's not a lot of space sometimes. So imagine there is only one cell here, that is F. So if you're opening a page which has multiple pages and you need to, that data needs to be loaded into that single cell, it can't happen. It can do only one page at a time, or else you need to give the whole space for it to run. So considering you have only one cell, so it can have only one page at a time. So here we use the page replacement concept. So what happens is, your operating system takes that one page which you're going to read and will place it in the F cell, that F cell, and you can read that page. When you're going to read another page, it is going to swap it with the next page from their storage, place it there and take back the other back to the storage. This is called page replacement. So let's move on. Now, need for page replacement. As a program runs, they may require more memory than the available physical RAM. It allows the page replacement helps to manage the memory efficiently by moving pages between the RAM and the disk. As I said, when needed, the page will be brought into the RAM and it will be put back into the storage, such a way. It allows the operating system to handle more processes that can fit in the physical memory. So by this method can also help in efficient use of your memory, the physical memory or the RAM. So let's move on. Page replacement algorithms. So there are various algorithms that are used to determine which page is to be replaced when the memory is full. So popular algorithms include such as FIFO, that is first in first out, LRU, that is least recently used, and the optimal. Each algorithm has its own advantages and disadvantages in terms of their performance, which we'll see now. So this is the first one, the first in first out algorithm. So in first in first out, they replace the oldest page in the memory. It is simple to implement but may not always provide optimal performance. So it is simple to implement, but there's not an optimal use. It can suffer from the Belady's anomaly, where the increasing number of frames leads to the page defaults. So when there are multiple amounts of pages that come, it will lead to a default because it becomes too compact for it to work. So you can see the picture here to understand. So as you can see, the first page is 7. So the 7 has been put in. The second page is 0 and 0 has been put in. The third page is 1 and the 1 has been put in. So 7, 0, 1 as it's going in the stack. Now the next page is 2. According to the first in first out, it replaces the oldest page. So you see 7 was the oldest one here. So 7 has been replaced with 2. As in such, the next one 0, 0 is already present there, so it doesn't needs to be replaced. Next is 3. Now 0 is the oldest one here, so 3 is replaced instead of 0, and so on. It continues until all the pages are completed. So let's see the next algorithm. Least recently used algorithm. Least recently used replaces the page that has not been used for the longest time. It is efficient but can be complex to implement. It helps reducing the number of page faults compared to the first in first out. So if you see the picture here, as you can see, first time 2 is inserted, and the second time 3 is inserted, and the third time 4 is inserted. Fifth time it is a 4, and 4 is already present, so it doesn't need to be, it's not replaced. Now it's in 2. I mean, sorry, 1. 2 is also not replaced. After 2 you come to 1. Now 1 has to be put in. It checks for the least recently used one. Which was the least recently used one? 3. As you can see, it is the least recently used one. It's not been used that many times. So you take your 1 and replace it instead of 3. Because see, if you're thinking why not 2, 2 has been there for so long. Before 1 it was 2, and 2 was already there. So 2 was placed there. Including 4, which came before 2, is placed there. The last 3 was used was after 2. So that 3 is going to be replaced with 1. So, and if you continue like that, you see after that the recently used was 4 rather than 2, so 4 is replaced with 3, and then so on, it keeps continuing, and you can see the changes. So let's see the next one. Now the optimal page replacement algorithm. Optimal replaces the page that will not be used for the longest time in the future. So in the previous one you saw which is least recently used. Now it only replaces the one which won't be used for the longest time. Meaning, if it will keep a track on which pages are going to come, and if it is not going to be used that many times, it's going to replace it. It provides the lowest possible page faults but is impractical to implement. So it's practically not possible like that. It's very difficult to implement, but it has been done a few times. So it is also used, it is not used normally because it has been used only as a benchmark to compare the performance of other algorithms. So practically it's not used in other algorithms. So let's move on. The clock algorithm. So clock algorithm is a simplified version of the least recently used algorithm. It uses a circular buffer and a hand to simulate the least recently used behavior. So it has a circular buffer, which means it can repeat the values, and it will have a hand which is pointing to the value. So it will be able to keep track easily, causing it the complexity to reduce a little bit. So you see, it offers a balance between efficiency and simplicity of the page replacement. So it makes it more simple to understand. Let's see the next one. Now let's see the working set model. The working set model is based on the idea of locality of reference. It defines a working set of windows that contain the pages accessed within a specific time interval. So like how you have the recently used file pops up on your computer or something, so it will have a track of which were the recently used pages, and it will keep them together, and it helps in predicting and managing the page replacement more effectively. So here you can see in the picture here the definition, which you can pause the video and read once. Thrashing in operating systems. Thrashing occurs when the system spends more time swapping pages than executing instructions. It leads to a decrease in system performance and overall the output. Page replacement algorithms play a crucial role in preventing the thrashing. So as you can understand, thrashing occurs when the system spends a lot of time in just searching the file rather than executing the instructions. So let's say the next one. Global versus local page replacement. Global replacement algorithms consider all pages in memory for replacement. The local replacement algorithms only consider the pages within the specific process for replacement. It is just like your normal programming where you have the global variable and the local variable. So same way this also works. The choice between global and local replacement depends on the system requirements. So there it is user based on the user requirement. Here it is on the system requirements. So now let's see demand paging and page faults. Demand paging brings pages into memory only when it is needed, and that is going to be tracked through the there is a table which will be made, which will be keeping track on like a secondary memory types, and will be keeping a track on which will be the needed ones, such as. So the page fault occurs when a process accesses a page that is not in the memory. A fault, so fault meaning, imagine you have pages 1 2 3, and your system tries to access the page number 4, which does, it's not in the memory, it's in the hard disk, it's stored somewhere else, it's not even in the memory, and it tries to access it. That is when the page fault occurs. So page replacement algorithms are triggered during the page faults to bring the required page into the memory. So the algorithms work when there is a page fault, and it is done to bring in that page into the memory so that the fault can be resolved as soon as possible. Now, impact of page replacement on performance. The choice of page replacement algorithm can significantly impact your system performance. Efficient algorithm can reduce the number of page faults and improve the response time. Understanding the behavior of this application is crucial in selecting the right algorithm. So all this together, they'll increase the performance of your system, which in turns makes your computer faster, which is one of the key features which is looked into while you're taking a system based on its processing capacity, etc. So in conclusion, the page replacement is a fundamental concept in operating systems for managing memory. Different algorithms offer unique advantages as well as disadvantages in terms of their performance, and choosing the right page replacement strategy is essential for optimizing your system's efficiency. So hope you understood something in this video. Please do like and subscribe. Thank you.